Welcome, I am Professor J. N. Mandal, Department of Civil Engineering, Indian Institute of Technology, Bombay. So far we are discussing about the shear strength of the soil. Now, if a saturated soil sample is loaded, a portion of applied stress goes to grain, another portion will be resisted by the pressure which will be developed in water called pore water pressure. So, the effective stress can be expressed as the effective stress is designated as sigma of dash. So, effective stress can be expressed as sigma dash is equal to sigma minus u, where sigma is equal to total stress and u is pore water pressure. Now, Coulomb give the expression for the equation in terms of the effective stress. That equation is Coulomb's equation is tau F is equal to C dash plus sigma of dash into tan of pi dash, where this C dash and sigma dash is the effective stress parameter, and in terms of the total stress also you can write tau F is equal to C plus sigma into tan of pi, where C is the cohesion and pi is the angle of shearing resistance, and this is in terms of the total stress, and C dash and sigma dash in terms of the effective stress. Now, in this equation we can write the tau F is equal to C dash plus sigma dash is equal to sigma minus of u. So, this is sigma minus u, this into tan of pi dash. So, these are the effective C dash and pi dash is the effective stress parameter. Now, shear strength is not an intrinsic property of a soil, but is varies over a considerable range with a varying condition, such as it depend on the density, it depend on the moisture content, as well as it depend on the degree of consolidation. The general method available for determine the shear strength of the soil. So, some of the methods are available for the determination of the shear strength of the soil. One is the direct shear test. So, we will discuss later about that what is direct shear test. Second is the triaxial shear test, and third is unconfined compression test. Unconfined compression test, and fourth is laboratory vane shear test. So, this direct shear and triaxial shear test on soil usually fall in three groups. So, these three groups are one which you call the unconsolidated, undrained test. Unconsolidated undrained. You can say also EU test. And second is that consolidated undrained test. Consolidated undrained test. And third is consolidated drain test. So, these are the different types of the test. It may be unconsolidated undrained test, U test, consolidation undrained test, CU test, or consolidation drain test. Now, the type of the triaxial that compression test and is drainage condition. This is very important, that what should be the drainage condition. So, what we do generally, that we do first of all, that how you have to prepare the soil sample. So, you prepare the soil sample and then you apply the load. So, it depends upon the what should be the drainage condition during the stage 2 and 3 of the triaxial shear test. So, first of all, that if the type of the test here is the unconfined compression test, which you can we say that UC test. So, after the preparation of the sample, what you have to do? You have to apply the self pressure, that means stage 2. First stage is the preparation of the sample, second stage is the application of self pressures only. So, if you apply the self pressure, so because it is unconfined, so there should be no self pressure, so drainage not allowed. So, this is very important for triaxial stage, when you have to allow the drain. And in the third stage, that means when application of additional axial stress at a constant self pressure, that means drainage not allowed. That is why it is undrained. So, you know that if it is an unconfined compression test, that means UT test. So, when application of self pressure only mean no self pressure, drainage not allowed, and when it is third stage, that application of additional axial stress at constant self pressure, that means drainage not allowed, hence it is undrained. Now, if the type of the test is unconsolidated undrained test, that means if it is a UU test, then stage 2 application of self pressure only, that means drainage not allowed, hence it is unconsolidated. And third stage, when the application of additional axial stress at constant self pressure, that means here also drainage not allowed, hence it is undrained, and that is why it called unconsolidated undrained test. And third case, if it is a consolidated undrained test, which you call CU test. In stage 2, after the preparation of the soil in stage 1, if in stage 2 is a application of self pressure only, that means in case of consolidated undrained test, drainage allowed, hence it is consolidated. And the third stage, when the application of additional axial stress of constant self pressure, that means drainage not allowed, hence it is undrained. And fourth type of test is consolidated drain test or the D test or drain test. In the second stage, the application of cell pressure, then drainage allowed, hence it is consolidated. And third stage, the application of additional axial stress at constant cell pressure, that means drainage allowed, hence it drained. So, one should know that when you have to allow the drain and when you are not to allow the drain. So, this is drainage condition during and stage and 3 of a triaxial shear stage is very important. Then you will be knowing what type of the test you are performing, whether it is unconsolidated undrained test, whether it is unconsolidated compression test, or it is consolidation drain test, or it is consolidation undrained test or unconsolidated undrained test. So, you will be knowing that what type of the test you are performing. Now, we will discuss that Mohr theory of rupture. Mohr represented that yield or the failure within a material is not caused by normal stresses alone reaching a maximum value, but by a critical combination of both shear stress as well as normal stress. The critical combination of shear and normal stress when plotted on a sigma 1 and tau coordinate from a line that is known as Mohr envelopes of rupture. Failure will occur if for a given value of sigma 1 the shear stress exceed that value. So, we can draw the Mohr envelope line. Now, what are the factors affecting the pi in a granular soil? Generally, there are 3 factors had important effect on pi. One is what is the particle shape. The more angular particle have the greater pi value. Second, gradation of the soil. Better the gradation, the greater of pi. And third is the relative density. Greater or relative density mean greater pi. Now, also this shear strength parameter affect the factors affecting the shear strength in clay. Now, the absorbed water plays important role in engineering properties of clay. Various possible effect of absorbed water, compressibility, neutral stresses and low permeability provide clay with almost unlimited variation in the shear strength value. So, these are the factor parameter which affect the moisture content. So, value of shear strength and shear strength parameter also vary. Now, what is the rate of load application? There may be slow or there may be quick test. If it is a slow loading, that is major and minor principal stresses are applied so slowly that neutral stresses are not changed at any time by added loads. This solution represent the stress condition in a cell developed by the construction lasting over a period of many years. It is also termed as drain test. In case of the drain test, because it drains, it takes a lot of time to consolidate it. So, it takes time, lot of time, that is why it is a slow loading test. Another is consolidated quick test. The major principal stress is applied so slowly that no change in the neutral stress occurs. So, the major principal stress is applied so rapidly that neutral stress carries all the additional stress. This is known as consolidated undrained shear, or which can be designated at CU. And quick loading, both the major and the minor principal stresses are applied so rapidly that effective stresses are unchanged and the neutral stress carries the additional load. This is also called the unconsolidated undrained shear test. The direct shear test, this is the simplest and the easiest of the plain shear test. A soil sample of size 6 centimeter into 6 centimeter into 2 centimeter in size is confined in a direct shear box, which has 2 dischargeable halves of same size. The soil sample in this shear mold is loaded vertically under different vertical loads and then shear off exactly halfway in between the sample. In this test, the plane of failure is predefined and 4 sides of the soil specimen are confined. So, what are the apparatus and the accessory required for the direct shear test? We will now explain that what are the accessory required. One is the direct shear machine with all its accessory. It is the static molding device, direct shear cutter, then saturation devices of direct shear cutter, perforated and unperforated grouped plate in pairs, porous stone, that is 6 centimeter into 6 centimeter into 0.5 centimeter in size, filter paper, measuring cylinder and vacuum saturation device. So, and apart from that, you require what is tray, spatula and static weight to load sample up to 4 kg per centimeter square. I am just showing one. This is the static molding device for direct shear test, and this is the MS plate. This is the remoulded soil specimen, and this is the gliding collar. This is the direct shear cutter, and here is the spacer block. This is 6 centimeter and this is 2 centimeter and this is 9 centimeter, and this is the guiding collar, that is about 6 centimeter, and this is the direct shear cutter and this about 6 centimeter. So, these are the static molding device for direct shear test. Now, I can show you this is the assembly of the shear box and the container for direct shear test. This is the lower part, this is base plate, and these are the upper part, and this is the loading pad, and this is the shear box whose size is about 60 into 60 and the 50 millimeter, and here is a pin to fix the half of the shear box, and this is 50 centimeter, this is 60 by 60. Here is a base plate, there is a grid plate, and this is the U arm, and this is the container for the shear box. So, soil will be assembled here and compacted, and this is also lower part soil, upper part soil, and there is a shear in between the half of the shear box apparatus. So, it is shearing, it is in this direction and it is in this direction. So, from this is the assembly of the shear box and container for the direct shear box test. So, how to assemble the sample and how you can perform the shear box test. This is I am showing this is the direct shear box test apparatus. What I separately explain you, this is all direct shear box test. Okay. In which the shear strength parameter of the soil is determined using this shear box test. This also direct shear box test, you can see here, you can see here, this is the proving ring, you can measure with the help of the proving ring. This is the horizontal dial gauge, and this is the vertical dial gauge, this is vertical dial gauge, and this is the shear box. Okay. This is the shear box. So, you can measure the proving and then load is applied. Okay. Under what load, what should be the shear, what should be the horizontal dial reading, and what should be the vertical dial reading. So, which you can measure from the shear box test under different loading condition. So, which I will explain you later. So, next is also this is large scale direct shear box test. Sometimes some material which you cannot determine the direct shear test from the small scale shear box test, which is 66 centimeter into 30, you require that large scale direct shear test. And in the large scale direct shear test, this is your shear box, which is about 300 millimeter into 300 millimeter. This is the size, and the displacement rate is about 0.05 millimeter per minute. So, when the soil sample that aggregate, this is larger size of the aggregate, then you have to perform the test using the large scale direct shear box test. Or if you wanted to perform any geogrid material or geotextile material, it is always recommended to use the large scale direct shear test instead of the small scale direct shear test. So, you can have the appropriate result. Now, how is the procedure for sample preparation. That is clay, it should be undisturbed. The sample cutter of standard size of 6 centimeter into 6 centimeter into 2 centimeter of direct shear test is oil on the inner side, gently press into natural soil chunk and the sides, and top and bottom is trimmed straight, and this sample can then be passed generally into the direct shear mold. If it is a clay remoulded, it is prepared by kneading at the required moisture content depending on the density of compaction. So, how much you are compacting the soil sample? The amount of wet soil is calculated for the volume of 72 cc and then weighted. If it is a sand remoulded, the calculated quantity of sand needed to obtain the void ratio is tamped in the layer into the direct shear mold to the required height. Now, the test is that you have to check the apparatus is checked, then the test specimen is prepared, then apparatus is assembled and load hanger is fitted to it. Then vertical dial gauge is set, water is added in the water bath for submerged test, and this should be avoided for dry test. Normal shear stress is applied. The top up of the box is lifted using lifting screw and shear is applied through the given mechanism. The load is removed at the end of the test and box is drained. The shear box and the specimen is removed and water content is measured. Repeat the stage 2 to 9 using at least 2 other specimen at the different normal loads. Then plot curve of shear stress versus axial or the horizontal deformation. Then construct the Mohr circle and determine the major and the minor principal stress. So, with this kind of the test you can determine that what should be the shear stress, what should be the axial and the horizontal deformation, and then you determine what will be the major and the minor principal stress under this condition. So, this will be very parameter, shear strength parameter will be very useful in geotechnical engineering. Thanks.